What's up, guys? I hope you all are doing well. Welcome back to my YouTube channel and welcome back to another YouTube video. In this video, we will be looking at part 6 of our Scientific and Numeric Computing in Python tutorial series. In this video, guys, we will be looking at some more of the features and functionality that NumPy has to offer us, as well as those operations that are supported by NumPy arrays. So let's get to it. I created a new Python cell, in Spider IDE. I will import NumPy as np. Now, I assume you guys are familiar with the basic operations that standard lists in Python, can support. These operations being indexing and slicing. So those are two basic operations that we can do on lists and arrays in Python. And the basic aim is that they allow us to sort of query the array itself, right? By query, I mean we have the ability to return certain values and so on. Now, the interesting thing is that, for example, if we were working with a standard 1D array in Python or list, anything you want to call it, the way in which we will go about, indexing this array would be basically the array name, and in a pair of square brackets, we'd pass in the index for the element that we'd like to access. Now, Python is zero indexed, so the first element has an index position of 0. Okay, so a list of 0 will give us that element, which is 1. Okay, now I can do this for all elements that are inside this list or array object. So 0, 1, 2, 3, and as you guys can see there. Now, another interesting aspect is that of, still pertaining to indexing, Python arrays and sequences, they actually support negative indexing as well. So starting from the back, okay, your index positions begin at -1, -2, -3, and so on. So -1 would print the last element basically in the sequence you are working with. By sequence, I mean a list, an array, a dictionary, and so on. Anything that supports iteration and has the ability to support indexing. So let's do a list of -1. As you guys can see, that's a value of 4. Now, slicing operations. So the difference between, indexing and slicing. Indexing is when we only specify one index to return one element. Slicing is when we specify sort of like a start and stop point. Okay, indexing returns a single element. That's what traditional indexing is, returning a single element from an array or list. And slicing is when we basically return or retrieve chunks, right? Multiple elements from that array. So chunks of the array itself. It's like you are returning a sub array of a larger array. So that's what slicing is. Now, Python does support slicing on its list and array objects. So I will give you a simple, situation or scenario. If I do 0 to all, we are still working with the a list object. So as you guys can see, right, 0 to all returns everything in that list that we are working with. If I do a list of colon, it will still return everything. If I do print a list, so I'm not sure if you knew this, but Python also supports slicing using the negative indices, right? So suppose I want to slice from, let's assume I want to slice from negative, so there's 4 here, so -4 to -2. And as you guys can see, that is the first half of the array, -4 to -2. And I should mention that the stop index is exclusive. Okay, Python slicing and indexing as well, it is exclusive of the stop index. So that's good to know. Now, if I want to do a list, maybe a -2 to -1, that returns me with just 3. Now, if let's copy and paste this. If I take out the -1, as you guys can see, I have the remainder or the remaining portion of that array. It has been sliced. So that is interesting. This is slicing, a simple slicing operation. So it is nothing too difficult. Even if it is your first time learning about indexing and slicing, it's quite interesting. Okay, so I should also mention to you that what we've just done, it was using a standard Python list. It was not a NumPy array. Okay, now we shall actually proceed to test out a few of these slicing and indexing operations using a NumPy array. And I also will point out one or two differences here and there, just so you guys know, the next time you are working with a list and a NumPy array, you know what operations and how to go about performing these operations on each object. So I will basically take that A list object we had and I'll convert that into a NumPy array. As you guys can see, that is a NumPy array. So type of array, there we have it here. It's an ND array. That's good. So we now know that we are slicing and indexing a NumPy array. So I would like to go back one step. So what we just did just now, right? It was using a one-dimensional array. A list was a one-dimensional array. If you look up here, this is the standard array that we typically work with in Python, especially if you're a beginner. Now, lists and arrays themselves have the ability to be multi-dimensional. You can have them in multiple dimensions. It's just that it's not as fast, when compared working with a NumPy ND array. So assume we have the same elements, 4 elements, 1, 2, 3, 4, but we just have them in a different format or a different representation. Now we have a 2D list. So if I want to perform a simple indexing operation, I would have, or I would be required to have, two pairs of square brackets. Now you may ask why. Now this is an index operation or indexing operation, which means I want to receive or retrieve one specific element from the array or list that I am working with. Now suppose we would like to have 1, right? We would like to return 1 from the array. Now what we would do is we'd have to specify, think of it as a table. We'd have to give within the square brackets the location of that value, and we'd have to pass basically the row and the column in which that value sits. So Python is 0 indexed as well, right guys? Remember that. So first, in the first square brackets, we'd give the row. 1 is sitting in row 0, and the column 1 is sitting in column 0. Now if I run this, you guys will see we have 1. Okay, so this can be done for all the elements, right? Element 2 is sitting in row 0, but it's sitting in column 1. Element 3 is in row 2, which is basically an index of 1, and it's sitting in column 0, which is as is. Element 4 is in row 1, but it is in column 1. So I run this, and as you guys can see, we have 1, 2, 3, 4. We've indexed each element individually using the appropriate list syntax. Okay, so if you would like to slice this list object, what you can do is a list all. It's very similar, guys, to what we've actually looked at above in the 1D array. So a list, suppose we'd like to receive only the first row of elements. So same procedure. We'd specify the rows we'd like. So I want row 0 and I want all columns. And as you guys can see, I have column 1 and 2, which is basically all the columns, and I have only row 0, the first row, in which 1 and 2 were sitting. So that's that. Now I can also, do the same if I would like to index several rows from our array. Let's assume we'd like all rows, and let's view what this gives us. So having a single colon with one pair of square brackets will give us everything in the array. Now that's fine. We can add a comment here. We can say basic indexing and slicing operations on a 2D array in Python. Now I would like to take us to explore indexing and slicing, but on a NumPy array. So coming back to what we've had earlier, right? This is our A list, the standard Python array. It now has been converted into a NumPy array. And you remember earlier on we ran this code and it was an ND array. Now let us proceed to index. Indexing is easy. It does not differ much at all. So I'll run that again. I will come here. I'll just type a list. So just so we can view the array itself. Now, suppose I would like to retrieve element 1, this one here. What I would do in my square brackets is 0 and 0. And I run, and you guys will see, and you should realize that indexing a NumPy array is no different from indexing a standard Python list. So 0, 0, 0, 1, 1, 0, 1, 1. And I should have 1, 2, 3, 4, which I do. Now, let's proceed further. This is where it gets a bit interesting. NumPy arrays support very powerful slicing methods. Okay, now this is where the first and I think most important difference arises between slicing, a NumPy array and slicing a traditional Python array or list object. So the difference lies in the square brackets, as you will see. Suppose that now you guys know, right? I have ARR, which is this array here. It's got rows, it's got columns. What if I wanted to have, all elements, in column, maybe column 1, which is basically 0. I want to receive or retrieve only elements 1 and 3 because of the fact that they are in the same column. So this is what I mean. To retrieve all the elements in a certain column, all we have to do is the name of the array, open a square bracket, and you will utilize a comma to separate the rows and columns. Okay, this is important, guys. So I told you we want all elements in the first column. I do a colon to specify that I want all rows. I do a comma, as my separator, and I specify 0 for the column. So all rows, but only column 0. So print, and as you guys can see, 1 and 3, if you look above, 1 and 3 are in column 0. So that is interesting. If I do array all, comma, 1, this will give me 2 and 4. So this is something I want to try for myself. All of -1. Let's see if this works. So it does. You can, right? Specifying -1 is an index telling us that we want column -1, which is the last column. So that works out well. Now, that is interesting. So print. Now, if you would like to access columns, right? Accessing basically, the bottom row. What you would do is array row 1 all columns, and as you guys can see, 3 and 4 are returned. Now ask yourself why. It's because I just told you that array 1 tells me that I want row 1 in the array, and I want all columns in row 1. And this explains why we see 3 and 4, because 3 and 4 is actually row 1, and it's the elements in row 1. So that explains for output we see here. Okay, I hope you guys are finding this interesting. You can comment down below if you like the tutorial up to this point. So let's move on. Now I'd like to mention to you, right, that what we just saw and what we just did was indexing and slicing, but on a NumPy array. And as you can tell, it's powerful. Okay, now you see, sometimes when working with Python, right, on your journey with Python, maybe you're a data scientist, you're a data analyst, a data engineer, or whatever, right? But the point is, sometimes there may be situations that occur in your journey with Python where you require some sort of I would say criteria or filter, right, on your index or slicing operation. Now, believe it or not, guys, NumPy actually supports that, right? It is known as conditional indexing, okay? Conditional indexing or conditional slicing, okay? And NumPy gives us that functionality, okay? The most common one we have is, okay, so I'll type it here for now. The most common one we have is np.where, okay, and where allows us, and as you can see, it can be used on multi-dimensional arrays as well, but the point is, where will it allow us to provide some criteria or filter with which to filter the elements that we have. And yeah, you can basically return the indices that you desire. So regardless of dimensions and so on, based on just the conditions or criteria that you provide, you will be able to filter your elements in the NumPy array. So I will give you a simple example now. So I will create another cell. I'd like to work with a simpler array. So this is just for you to have an insight into NumPy's possibility. Okay, possibilities. So array is equals to numpy.arange. Let's say we want an array, 5 elements, 0 to 5, a 1D array. Keep it simple for now. Now, what I will proceed to do. So I think here I'd like to comment. So let's do conditional, spelled that wrong, conditional indexing and conditional slicing. So that's that. Create a NumPy array. That's fine. Now next, create the NumPy array, create the index array. So index is equals to numpy.where array is greater than 2. Now take a moment to understand, guys. So if you are confused, don't be, because this is very simple. It all stems back to the fact that I told you in an early part of the tutorial, we spoke about a concept. This concept is called, I hope you guys remember, broadcasting. Okay, broadcasting allows us to actually impose this criterion on our arrays. Broadcasting was that process whereby elements are affected individually, which explains why in the where method that's provided by NumPy, we have the ability to just utilize the array itself. We said where array is greater than 2. So I'd like you to think of this as a two-step process, okay? Think of it as a two-step process. There are more steps involved, which we will look at as we go along with this example. But for now, think of it such way, you have this array already. Now, what you're going to do is create a filter. You're going to impose it on the array, which is done using this step here. Index is equals to numpy.where. And what's going to be the result of this is indices, right? It's going to be a list of basically indices. And if you print the index, you'll get the indices of those values that basically support your condition. Okay, so we'll have a look at that as we move along. Anyway, index is equals to numpy dot where array is greater than 2. Now you may be wondering, what does index hold? So I print index, and as you can see, it is an array and it's storing 3 and 4. Now let's view array itself. Array is this. Okay, okay, I create a new cell. Now guys, you understand, right, that we just viewed r was this, the array itself, and index is that. Keep that in mind, pay attention to that. So now what we are doing is we are creating a, so let me remove that, I'll add a comment, create the new desired array. New array is equals to array index. Okay, now this leads me to talk about another cool and interesting concept. It is called fancy indexing. It create the new desired array. It utilizes a concept of a concept called fancy indexing. So we should have spoken about this earlier, but no stress, it is a simple operation. Basically, you know how we were working with, it was a list. Yes, a list. So let's do a type of a list. So no, actually what I will do, I'm in the IPython console now. I just want to demonstrate something for you very quickly. So let's just call this arr1 is equals to numpy array. Let's just say I have 1 2 3 4 5 6 7 8. It's a boring array, yes, but anyway, type of arr1 is a numpy. Fine, that's what we want. NumPy arrays support this technique that I am about to show you, fancy indexing. Now, I explained to you earlier, indexing is a simple process. We pass one index, we get one element. Fancy indexing is the opposite. You pass multiple indices and you get multiple elements. Individual elements, they may not be consecutive. That is the difference between slicing and indexing. Slicing tends to be consecutive, as you saw. Indexing is not, or does not have to be, consecutive. Now, a simple demonstration, R1, if I do R1 0, the reason why I'm using 1 square brackets is because it's a 1D array. Anyway, 0 will return 1, fine, as we expected. Now, if I do R, maybe I want to have R, let's keep it simple, maybe do 1, I get 2. If I do 2, I get 3. Fine, but now that is cumbersome. I want these 3 elements specifically, right? Elements sitting at index 0, 1, and 2. Yes, I can access them individually, but that's not feasible, especially in programming. So what we do is we pass the indices that we want in a list. Okay, so this is the list. I will cut that, right? So let's build the fancy indexing syntax from scratch. First comes the name of the array you'd like to index. Then you'd have one pair of square brackets. Within this, we'll place the values, but the values themselves need to go inside a list. So I have a second pair of square brackets and I do 1, or let's do 0, 1, and 2. And when I run this, you guys will see I'll be outputted with 1, 2, and 3 all in one list, as you guys can see. I hope you guys understand. That's really all you need to know about a process called fancy indexing in Python. Okay, NumPy arrays support them. So the two-step method I was talking about earlier, the first is where we basically set up the decision making and we grab those indices, the indices of the elements that meet our condition. And the next or second step as part of this process of conditional indexing and slicing is where we actually take those indices and we fancy index it against the original array, and that gives us a new array containing the elements that met our criteria. I hope this makes sense to you. So new arr. As you guys can see, we have 3 and we have 4. So index, and this is, yeah, let's print arr. This was what we started off with, and then we have new arr. So let's talk about this, right? This was the array we had. We set up a condition on this array here, right? The condition was arr is greater than 2. Greater than 2, right? Equals 2 was not an option. So the only 2 that's greater than 2 here is 3 and 4, sitting at index positions 0, 1, 2, 3 and 4. Okay, so that is kind of silly. I should have used a different example, but you get the point, right? That this is simply coincidence that the indices of the values are actually equals to the values themselves. I guess because it's because we use the arange function, right? Arange begins at 0. But I am sure you guys get the point. So that is interesting stuff. Now, let's move further. Now, you see, certain times, what we just did is we created a new array, right? Now, oftentimes, maybe, you know, you have a preference, or, yeah, it's your personal choice or whatever, but sometimes you'd like to use the original array and you'd want to just take out the values that didn't meet your criteria. Okay, to do this, we have the np.delete. So I will add a small comment here. Use the np delete function to delete the elements that did not meet your criteria in the conditional slicing or indexing operation. So that's fine. Now, basically what we can do is, it is as follows. So new array is equals to np.delete, and within this, so as you can see, this function will return a new array with sub arrays along an axis deleted. So that's not important. All you guys need to know is that you have a new array, and it's basically taking your original array, the one you want to perform the indexing on, and you want to have the list of those indices. So array comma index, print new arr. Output will be the same, guys. Okay, guys, so what you see here, right here, 0, 1, 2, that there is basically the resultant elements of the array. So basically what happens is that the numpy delete, right, we pass in the array that we are working with, which was this one, and we pass in the indices of the values that we want to remove. If you recall, these were the indices 3 and 4, which explains that 3 and 4 was removed from the array, which is why we are left with 0, 1, 2. So it's kind of like the reverse operation compared to the way. So I hope that makes sense to you. Now, coming back to our example, right, I would like to share one more interesting feature that deals with conditional indexing and slicing. So here, suppose now we have, our same array that we've been working with. Okay, now I will copy and paste this for us. Okay, so r is equals to numpy.arange5. Now what I will do is, we are still on the concept and topic of conditional formatting, but here we are talking about conditional indexing and slicing using Boolean arrays. Okay, it is nothing difficult. It really, if you understand the concept of broadcasting and how it applies itself to numpy arrays, then this is all easy stuff for you to understand. So you see, broadcasting allows element by element operations, and essentially what we are saying is that if I have now a sort of condition that's going to test whether my element at that specific index meets the condition, then obviously that element at that index would be included in the list of indices. But now, otherwise, it won't. Okay, so R is still the same. What we are doing here is index is equals to R is greater than 2. R is greater than 2. This logic will be applied. So R is basically element by element. Each element in the array called R, which is up here, would be taken and compared to check if it's greater than 2. Okay, so let's proceed to print index. And as you guys can see, we have an array that's basically containing a list of booleans, and these booleans tell us, you know, basically the answer to that comparison for each element. As you can see, I've just printed out the array itself, and here we have the booleans. So essentially what broadcasting did was it looked at 0, is 0 greater than 2, false. It looked at 1, is 1 greater than 2, false. Is 2 greater than 2, false. Is 3 and 4 greater than 2, true and true. I hope that makes sense to you. This is known as Boolean arrays, or using Boolean arrays to perform conditional indexing and slicing using NumPy in Python. Okay, so what we can do afterwards is new array is equals to array of index. Print new array, and as you guys can see, only those where true is displayed, or where the comparison evaluated to true, those are included in the new array. So I hope that makes sense to you. Now you have the ability to pick whichever method you want to use. Okay, I think it all stems down to your preference. I just showed you 2 ways that you can use. I'm not sure 2 or more ways, but we discussed ways you can utilize conditional indexing and slicing to help you facilitate that filtering of your NumPy arrays. So that was an interesting session. So in the next video we will take it from here, guys. I hope you found this one interesting. Thanks for watching. Thanks for staying till the end of the video. Good luck with your work, and I'll see you in the next YouTube video.